Welcome to homework.
We are given a set of positive integers defined by basis step and recursive step. So this set is a set of positive integers s such that 1 is an s, and if n is an s, then 3n plus 2 is an s, and n squared is an s. In part A, we're asked to show that if n is an s, then n is congruent to 1 mod 4. So we'll do this proof by induction. So for the base case, the only positive integer for the base case is 1, which is clearly congruent to 1 mod 4. So the property holds for base case. Say P1 is true. Now for the inductive step, let n be a positive integer in S such that n is congruent to 1 mod 4. And so it follows from the rules that we derive that 3n plus 2 is an S, and since n is congruent to 1 mod 4, it follows that 3n plus 2 is going to be equal to 4n minus n plus 2, which is congruent to 4n is going to be, of course, congruent to 0 mod n, so this is 0 mod 4. And then n is congruent to 1, so negative n is congruent to negative 1 plus 2, which is equal to 1 mod 4. So we've shown that 3n plus 2 is congruent to 1 mod 4. And now we also have that n squared lies in S, and n squared is going to be congruent to 1 squared, which is equal to 1 mod 4, since m is congruent to 1 mod 4. And therefore, by the principle of structural induction, it follows that any element of S satisfy this property. And so it follows that if n is an S, then n is going to be congruent to 1 mod 4. In part B, we're asked to show that there exists an integer m congruent to 1 mod 4 that is not an S. So now, to do this, this is really sort of a trial and error thing. So thinking integers that are congruent to 1 mod 4, well, we have that 1 is an S, and so it follows that 3 times 1 plus 2, which is 5, is an S. 5 is congruent to 1 mod 4, What's the next number that's congruent to 1 mod 4? Well, we have that 9 is congruent to 1 mod 4. However, 9 is not an integer added by the basis step. Since 9 is not equal to 1. Okay, and let's consider the possibilities. We have that integer 1 adds 3 times 1 plus 2, which we said was 5, and also adds 1 squared, which is just 1. It's the same thing. Neither of these are 9. We have that 5 adds 3 times 5 plus 2, which is equal to 17, and 5 squared, which is equal to 25. But of course we have 9 is going to be less than 17 and 25. So it follows that 9 is not an element of S.